Hi, in this video we're going to look at the fifth rule for exponents. When we have a term in a bracket and an exponent outside of the bracket, we multiply the exponents together. Let's look at some examples. Simplify the following: 2 squared with an exponent of 3. So we say 2 to the power of 2 multiplied by 3. 2 times 3 is 6, and we get 2 to the power of 6. What about y cubed all to the power of 2? So we say y to the power of 3 multiplied by 2. 3 multiplied by 2 is 6, and we get y to the power of 6. P to the power of 4 all to the power of 0. So we say p to the power of 4 multiplied by 0. 4 multiplied by 0 gives us 0, so we get p to the 0. And as we know from rule 2, anything with an exponent of 0 gives us 1. Also remember that an exponent outside the bracket affects the exponent of every variable inside the bracket. So here we have ab to the power of 2. Remember that a is actually a to the 1, and b is actually b to the 1. So we get a to the 1 multiplied by 2, which is 2, and b to the power of 1 multiplied by 2, which is also 2. 2, even though it is a constant, is actually 2 to the power of 1. So we're going to get 2 to the power of 1 multiplied by the outside exponent, which is 3. X is also x to the power of 1 multiplied by 3. Y squared multiplied by 3. 1 multiplied by 3 is 3, so we get 2 to the power of 3. 1 multiplied by 3 is 3, so we get x to the power of 3. And 2 multiplied by 3 is 6, so we get y to the power of 6. 2 to the power of 3 is actually 8, so our answer becomes 8, x to the 3, y to the power of 6. The one thing you need to remember is that the exponent only affects the bracket. It does not affect any terms outside of the bracket on the side. So in this case, the exponent of 2 will not affect the 5 over here. So let's write down our 5, open our bracket. 4 is actually 4 to the power of 1. We're going to multiply the exponent by 2. X to the power of 3, and multiply by the exponent of 2 again. Let's leave our 5 outside the bracket. 1 multiplied by 2 is 2, so we get 4 to the power of 2. X, 3 multiplied by 2 is 6, so this becomes x to the 6. 4 squared is actually 16, so this becomes 5, open bracket, 16, x to the power of 6. Finally, we can multiply the 5 by the coefficient of 16, and we get an answer of 80x to the power of 6. Now, the exponent outside the bracket affects every variable inside the bracket in the term, even if we're working with a fraction. So if we have a over b to the power of 2, this becomes a squared over b squared. Let's look at another example. Simplify the following: 3a over b squared c all to the power of 2. Because we have got so many variables here, let's spread this out a little bit. 3 is actually 3 to the power of 1, so we get 3 to the 1 multiplied by the exponent of 2. A is also a to the 1, so we get a to the 1 multiplied by 2 over b squared 2 multiplied by 2. C is actually c to the 1 multiplied by 2. 1 multiplied by 2 is 2, so we get 3 squared. 3 squared is actually 9. 1 multiplied by 2 is 2, so we get a squared all over. 2 multiplied by 2 is 4, so we get b to the power of 4. And 1 multiplied by 2 is 2, so we get c to the power of 2. Let's do one more example. This is quite intricate, so we're going to break it up into steps. Remember that the exponent of 2 only affects the bracket. So we can say 3, which is outside the bracket. 2 is actually 2 to the power of 1. So we can say 2 to the power of 1 multiplied by the exponent of 2. A to the power of 3 multiplied by the exponent of 2. Let's close our bracket. The denominator of the fraction does not have a bracket, so it is not affected by this square over here. So we can just say over 6a squared. Now let's multiply our exponents out, and we get 3, open bracket. 1 multiplied by 2 is 2, so we get 2 squared. 3 multiplied by 2 is 6, so this becomes a to the power of 6, close bracket, all over 6a squared. 2 to the power of 2 is actually 4, so this becomes 3, open bracket, 4a to the power of 6, all over 6a squared. Let's make some more space. The next thing we want to do is we want to multiply this 3 over here out. 3 times 4 is 12, and we get 12a to the power of 6 over 6a squared. But we're not finished because we still need to simplify this. 12 divided by 6 gives us 2, so we can say 2. And now we have a to the power of 6 divided by a squared, so we can say a to the power of 6 divided by a squared, which means we can subtract 2, and we get 2a to the power of 4. And we have completed this question. We will look at more examples like this in upcoming videos.